Okay, so let's go on to the separating techniques and remove this colloid and all things from here. And so now I've told you about the three types of mixture: solution, suspension, and colloid. The question arises that when I form the mixture, how do I separate it? Compounds, they can be separated only by the electrochemical processes, but how do I separate a mixture? Different types of mixtures are found. How do I separate them? So this question is going to be resolved in this session, that is the separation techniques. To make your journey small and interesting, I'm going to give not whole of the activities, but just a small introduction and a brief, intro of what the separation technique is like, and then I'm going to go on. So, if you want to, just remove iron fillings from sulfur, how do I do that? It's very easy, my friends. If you have to remove iron fillings from sulfur, take a magnet, put it over the sulfur, and all of the iron fillings would be attracted by the magnet, and all of the iron fillings are removed from the sulfur, and so you get two constituents of it without any hard work. So it is by a magnet. Then what if you want to separate a dye from blue-black ink? That would be basically by evaporation. So, it would be basically by evaporation. I cannot directly put on the dye on the flame, otherwise it would be a great disaster, because it's such a small amount of dye, and upon such a large ignition temperature it would burn the container completely. So I'll put some water beneath it, and upon it I'll put the dye. After some time, the solvent of the solution would be evaporated, that is normally water or alcohol, and only the dye would be left. So you can separate this dye from blue-black ink. And the principle behind is that you can separate the volatile substance or the solvent from the non-volatile solute by evaporation. So this solute was not evaporative. This dye was not so evaporative. So we got the volatile substance out of it. Okay, so now let's go on. What if I want to separate butter from cream? You will give a simple answer. Put it in the mixie, revolve, 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 and I'll get the butter. But what is the principle behind it? We are studying science. Yes, we will centrifuge it. So, when we centrifuge it in a mixie, the denser particles are forced at the bottom. So when you revolve it, the denser particles of the cream are forced at the bottom, and the lighter particles stay at the top. So when spun rapidly, so you get the butter out of the cream. This is how you centrifuge it. In the clothes, it has several other uses, like in dairies it is used. It is used in a washing machine to squeeze out water from clothes, etc. So many uses of this separation technique, centrifugation. And you also use it in a laboratory to just extract, just test blood or urine. That means different constituents of the blood and different constituents of urine can be tested through this centrifugation technique. what if I want to separate water and oil? Seems easy but is not. You will need a separating funnel for that. See, water and oil are two immiscible liquids. That means that they are not mixed with each other. That means that water does not mix inside oil. So they form two different layers. So you can put it into a separating funnel. You can just open its bottom or its cap. Let the first layer drain out and then the second layer would be left. So the two layers are separated. This is how you can separate two immiscible liquids, be it any. And this can be helpful for separating water from oil and extraction of iron from its ore. This is also done by this technique. My friend Tino recently had a problem. His teacher gave him a solution of salt and ammonium chloride to separate. And so he had a problem. He gave it the solution to me and I quickly separated it. So you might be wondering how I did. I just picked the particles of ammonium chloride and dropped them outside. No, that's a wrong method. What I did was I applied might, not like Tino. He is an idiot. What I did is that I took a funnel, glass funnel, big one, in which I put the mixture. I put a cotton plug upon it and then I heated up the mixture. As you know, ammonium chloride is a sublime substance. It evaporated quickly and only salt was left. After some time, I cooled the solution. And the layers of ammonium chloride were found on the, top inner layer of the container. So I separated the ammonium chloride and salt and Tino was very happy. And this principle is that you can separate a sublime substance from a non-sublime substance and directly, and sublime substance, because the sublime substance which will convert from solid to directly to gas and then can be cooled to get the solid. So this is how you can separate it. Tino was given another mixture. He said that I want to separate different colors from a dye. Oh my god. But I did it as quickly as I could. You know how? Let me tell you. Before I told you how to separate dye from blue black ink, and now I'm going to tell you how to separate different colors from a dye. Because a dye is usually composed of different colors: blue, black, green and yellow, pink and green. It depends upon the type of the dye. So how to separate it? What I did, the technique I used was the chromatography, in which I put a dot on approximately 3 cm from the base, and then I put it into the water, refraining that this dot should be put inside the water. And after some time the water started travelling up and taking this dot along with, and the color which was more soluble in the water travelled a higher distance and the other things travelled a low distance. So this is how the different colors were separated, and Tino again was filled with joy and thanked me. So this technique can be used to separate colors from a dye. So if you have to separate two miscible liquids, is that they mix with each other nicely, two liquids, then what will you do? It's easy. If they have a difference of 25 K or 25 Kelvin in their boiling points. Then they can be separated by distillation. The process of distillation is that you have to set up a distillation flask in which there is a cooling area and there is a boiling area. When the substance is boiled, if I draw it, when the substance is boiled, it is taken into a tube and here in the vaporized form, and here it is cooled, and again you get the liquid. But this technique can be used only if there is a difference of 25 K between the boiling points of the two liquids, of the two miscible substances. If they are having a boiling point less than 25 K, then you will have to add a fractionating column, which is usually the most basic one is a glass tube packed with glass beads, so that your first substance can be cooled out easily. So this is called fractional distillation. Now, after this fractional distillation and distillation is also used for separating different constituents of air from mixture of air. Okay. Now let's go on to crystallization. Now again, if you are getting confused, where does this crystallization lie in the world? Then I'm going to tell you so that you don't get confused. In NCERT, it's on page number page number 23. So yes, it's on page number 23. And so crystallization is an process by which two particles mixed in a mixture are separated in the form of crystals. This is known as crystallization. A better definition is given in the book. Crystallization is a process that separates a pure solid in form of its crystals from a solution. So a pure solid in form of a solution, in form of crystals from a solution. In an impure solution, copper sulfate can be separated in form of crystals. Now you might be thinking we can use evaporation or any other technique such as hand picking, etc. Why this crystallization? Okay, there are many things. That is, when you heat those solids, like sugar gets charred and they get decomposed as well. So crystallization is better than that. And solids and impurities may still remain inside them even after evaporation. And some may get even excessively heated up, etc. And some more things to happen. So crystallization is a better process. Solids may get decomposed, they may get charred, and impurities may still remain. So crystallization is a better process. So what are different applications? It is used in purification of salt, separation of crystals of alum from impure samples, and water, and separation of copper sulfate from impure samples to use in the laboratories. And now let's go on to the water purification system, which is given on page number 24 in your book. I'll just let you know because it's a very brief topic. How is water purified? It's a very old method of purifying. There are new techniques coming up, but still we're gonna use this. In a reservoir, then it goes to the sedimentation tank. Goes to the loading tank. goes to the filtration tank. And then it goes to the chlorination tank. And then comes to your home. So, in the sedimentation, all the impurities are let to settle down so that you get a pure sample of it. And in the loading tank, to sediment the suspended impurities. So the suspended impurities inside it are also sedimented inside this loading tank. And in the filtration tank, there are gravel, sand, and so filtration types of things are kept in which your water is filtered. And then if the microorganisms are still left inside it, then they are killed in the chlorination tank. Then the water comes ultimately to your house. And as I have already said, it's a very old method of filtering your water, and now new techniques are coming up. And thank you for watching this video, and I hope you liked it. And please remember to like, subscribe, and view and share my videos, and visit my YouTube channel Dashing Doll for other such educational